Well, welcome everyone. Time to get started, I guess. I'll record this session and put it on Confluence for future reference. If you have any questions during the presentation, just type them into link and I'll try to keep an eye out for them. I'll also try to answer any questions you may have at the end. So as the title of the presentation indicates, it's primarily for people who have little or no experience using TeamCity. My goal is to get you interested and tell you what you need to know if you want to get started using TeamCity. So let's see what I plan to cover. First, I'm going to quickly mention what I mean by continuous integration in this presentation, and we'll give a few examples. Then I'm going to introduce you to TeamCity and explain some TeamCity concepts before demonstrating actually how you use TeamCity for continuous integration. So, in the narrowest sense, continuous integration means to continuously and frequently merge code changes from a group of developers. The goal here being to avoid integration problems. If you have developers who don't integrate frequently, their changes will probably diverge and you'll waste a lot of time trying to clean it up when they eventually do integrate. In a broader sense, continuous integration is a process where code changes in a project are built and checked or verified in various ways automatically. When you have multiple people working on a single project, it's very important that the code in the central repository always is in a working state, and continuous integration can help with that. It can also help to ensure that the code works in other environments than just the developer's own machines. But it's when you start to include a lot of other stuff into your continuous integration process that it really gets exciting. For instance, measuring code quality in a variety of ways, automating tasks like deployment of the application or generation of documentation, or testing beyond just the normal unit testing like security testing, acceptance testing, performance testing, and a variety of other tools. But let's start with a very basic example. So in this diagram, when the developers commit code changes, a process is initiated by some continuous integration software, for instance TeamCity. In a very basic setup, the most recent source code is built, some tests are run, and then the developers get feedback right away. And this setup is designed to very quickly get feedback to the developers. Ideally, this whole process would only take a couple of seconds, because if an error is discovered, the goal is that the developer won't be immersed in a new task, so it'll be inexpensive to fix the problem right away, as opposed to more expensive if it has to be fixed at a later point in time. So let's look at a more advanced example. So in this example, the process is not initiated by a developer committing a code change, but it's initiated at a specific time every day, let's say 5 a.m. So at 5 a.m. every day, the latest version of the code is built. And in this example, we're using MS Build to build a .NET solution. After that, MS Test is run, running unit tests, integration tests, or something like that. We may use .cover, which is a tool that measures code coverage. Then we run FXCop and StyleCop, which are static code analysis tools. Basically, they are looking for potential problems in the code. And lastly, we run Doxygen, which is a tool that automatically generates code documentation, and we publish that to a web server. So all of the feedback from that, when it's complete, will be available in the browser, or it could be sent by email. So when people come to work in the morning, they can look at the build results, test results, the code analysis, the documentation, and so on. And you can easily imagine extending this process much further with whatever you'd like, really. As I mentioned earlier, you could include performance testing, other types of testing. You can automate the deployment of the application, and so on. So in the previous example, we were mostly concerned with immediate feedback to the developers. But Here we're measuring quality in many different ways, and we do this every night, not just to know the current status of the project in the morning, but also to collect data for the future, to see trend lines, to track regressions and improvements and so on. So in this example, speed is not very important. Ideally, you want it to be complete when people come to work in the morning, but it's more important that it's run every day or so, just to keep track of the health and quality of the project. So there are many different software alternatives for continuous integration. I'm sure you're familiar with many of them, and this is some examples. We have Hudson, we have Team Foundation Server, we have Bamboo from Atlassian, we have Jenkins, and we have TeamCity. So TeamCity is programming language agnostic, which means it doesn't really care about what programming language you're using in your project. But TeamCity does have a lot of out-of-the-box support for .NET, Java, and Ruby. So if you're using any of those languages or platforms, you get a lot of configuration for free. TeamCity can build your project, execute tasks, and so on multiple operating systems, most importantly Linux, Windows, and Mac OS X. TeamCity supports 10 different version control systems, including Git, Team Foundation Server, and Subversion. And if there are ever any reasons that you want to use TeamCity but can't, that would be interesting for me to know, technical or otherwise. Okay, so a couple of TeamCity terms before we start the demo. Build agents is a concept that most continuous integration systems use. In the top right here we have the TeamCity web application, well, the TeamCity server, which is where the TeamCity web application runs. So when you connect to teamcity.visma.no in your browser, this is the server you're connecting to. But whenever you're executing builds, running tests, scripts, or anything else you do as part of your build process, that happens on a TeamCity build agent. And as long as we have enough licenses, we can connect as many build agents as we want and need to our TeamCity server. Currently we have 2 or 3 agents connected, but there's no problem increasing that number. And that's good because this system allows us to scale out, meaning that we can build many projects at the same time. We can just increase the number of agents. And it allows us to build projects in different environments, meaning that we can have different operating systems, other differences in software, or hardware for that matter. Last term is build configurations. And if you're familiar with Hudson or Jenkins, I think this is the same just as a job. I think it's just called a job in Hudson and Jenkins. If you're familiar with Team Foundation Server, it's the same thing as a build definition. Basically, it's all the configuration you need for an automated build process in TeamCity. So it includes stuff like when to trigger or start a build. That is number 5 in this picture. It includes where to get the code from and how, which is number 2 in this picture. And it includes 1 or more build steps that specify what should be done as part of the automated build process, which is number 3 in this picture. And it includes some other less important stuff as well, as you can see. So one overview / example of how continuous integration specifically works when you're using TeamCity before the demo. So here you have a developer in the top left that commits code to a version control system, like a Git repository, for instance. And someone has configured the TeamCity server in the top right to continuously monitor the version control system in the center. So when TeamCity recognizes that there has been a change to the code in the version control system, it has been configured to automatically trigger a certain build configuration. And at that point, TeamCity will look for a connected build agent that fulfills all the software requirements for this build configuration. So for instance, it could be that it needs a build agent that has Windows installed and Visual Studio installed. Now, if there are multiple available agents that fulfills those requirements, it will try to choose the fastest one. If all the build agents are busy with other builds, it will just wait in a queue until an agent becomes available, and it'll select the first one. After your build process has been executed on the build agent, the results are sent back to the TeamCity server, and the developer can browse the results either in the web application, he can be notified by email, or notified in other ways. Okay, so let's start with what you probably came to see. So I'm going to show you how to get started using TeamCity. In my example, I'll use a Git repository which is hosted on our Stash server. And if you want more information about that, you can find documentation and a Visma Training Center presentation like this about Git and Stash at the link on the slide. So I should share another screen, so hold on. Okay, so you will find TeamCity at teamcity.visma.no, and everyone in Depla should already have access. You can log in using your domain username and your domain password. If you are outside of Depla, you probably have to contact me and I'll grant you access. So here you can see on the front page we have 3 projects currently in TeamCity. We have Visma Auto Report, Visma Common, also known as the Visma Aurora platform, and we have the project I'm working on, which is Visma HRM International Payroll Core. And underneath each project, there are multiple build configurations. International Payroll Core, we have 5 build configurations, and let's just use a couple of them as examples. So the build configuration that's called development continuous. This line underneath the build configuration in each case is the most recent build. So you can see the build results for the most recent build. So for the development continuous build configuration, the most recent build was 7 minutes ago. It took 36 seconds. You can see who made the change. You can see what the change was about. This is the commit message. And we have an integration with Jira, so you can even see more information about the issue that Terje fixed. And you can click the link to get to Jira. The same thing for development nightly. We have a certain number of tests that passed, some more statistics about the build. You can see it was successful. It was last run 6 hours ago. It took 5 minutes, 27 seconds. And it produced some artifacts, some documentation, and a style cop report. But we'll get into that later. So the point being that one project can have multiple build configurations. So if you remember example 1 from earlier, the very basic continuous integration setup, where we have 1 step to build the application and 1 step to run some tests. That is what we're going to replicate now, because I think that's the most practical way of starting to use TeamCity. When you start using TeamCity, that's probably what you want to set up first. So the first thing is to create a project. And you need the project administrator role to do that. And if you're trying to do this and you don't have that role, just contact me and I'll sort it out. So you go to the administration menu and you click Create Project. And this project name will be on the front page, so it should be a very clear and concise name. Probably the Visma product name, if that's applicable in your case. I'll just call it VTC Demo Project for now. So there's no other important configuration on the project level, so we can just go ahead and add a build configuration for this project. So the same thing, we should have a good name for our first build configuration. If you remember from earlier, I named them, like, the first part of the name here is which branch I'm building from, and the second part of the name is how the build configuration is triggered. So here I'm building from the development branch, and it's triggered manually. Here it's still builds from the development branch, but it's triggered continuously, meaning every time a developer makes a change to the code. And here it's triggered nightly, and so on. But you don't have to follow that naming convention, obviously. I think this Visma report does it kind of like that, but yeah, just give it a good name. And none of the other options are very relevant at this point, so just naming the build configuration, and you go to version control settings. So now we have to tell TeamCity where and how to get our code before it can build it. And here you can see all the different version control systems that TeamCity supports. In our case, my application that we're going to build is in Stash. So I have a demo project here, I have a demo repo here, and this is the application that I want to build. This is the solution file. So the configuration will be very similar no matter which version control system you use. Basically, you specify where the version control system is and how to access it, like a username and password, and that's basically it. So in this case, I'll select Git. You should give your version control system root name a clear name. So let's do this because I'm building from the master branch. We need to specify the URL to our Git repository. And if you're familiar with Stash, you know that you can get that on the repository page in the top right text box. And if you have like TFS, you would probably specify the host name or IP or something. But for Git, it's URL. We specify the default branch, and this is which branch you want to build from. And the master branch is fine, because if you look at Stash, I have only one branch at the moment, and that's the master branch. Okay, one note about this option, the username style. So this is not a very important option, but it tells TeamCity how to link your TeamCity username with your Git username. And as I say, it's not very important, but you get a little bit of extra functionality if you do this correctly in TeamCity. So if you follow our internal recommendation, which is that your Git username should be your full name, then you select author name here. And then when TeamCity sees that your Git username is John Smith, then it can connect that to your TeamCity user. So the next step is to provide a username and password, because the Git repository, you have to authenticate to access it. So you have a couple of options when you do this. The first, maybe the easiest option, is obviously just I could use my own username and password. Then I would give TeamCity, I would allow TeamCity to log in on my behalf as my own user when TeamCity downloads the code to build it. Then TeamCity would have full access to, or at least the same access as you do, to the repository. So if you don't want that, you have another option, which is to create a dedicated user in the version control system. So that how you do that might vary from version control system to version control system. But if you're using Stash, we have two options. We have one shared user that is used among many projects that is called read-only. And this guy is only supposed to have the read-only access to your project. So you can see for my demo project, I have given this read-only user the observer role in Stash, which means that he has read-only access to my repository. And the password for this guy is read-only as well. So we can specify read-only as the username and password, and TeamCity would now be able to log in as this user and get the code. The one drawback is that if you want TeamCity to automatically create tags or labels for you, then read-only access is not good enough. In some cases, maybe you don't need that functionality or don't want it, and then this is fine. But if you want TeamCity to automatically create tags or labels for you, or some other operations that require write access, then you have to do what we did for the auto-report project. So let's look at the auto-report project in Stash. You can see that we created a custom user specifically for this project. And this user has a bit more access. He has the contributor role, so this user can actually write to the repository. And only the project lead has the password for this user. So it's a bit more secure. But in this case, we'll stick with read-only. And that's basically the important settings for the version control system. So we'll just test our connection. Everything is okay, and we save that. And here you can see the settings for automatic labeling. So if you wanted to, we could say that after each automated successful build, we want TeamCity to create a tag that is called build dash and then the build number, which is automatically incremented by TeamCity for each build. But let's not do that. Okay, so we go to add our first build step. And here you can see all the types of build steps that are supported by TeamCity. So you see a lot of .NET stuff, you see a lot of Java stuff, you see some Ruby stuff, and you have one command line build step, and you have one PowerShell build step, which allows you to basically do anything you want. But this is the free configuration I was talking about, all the other steps. So we are going to build a .NET solution. So we have a couple of options. We can use MS Build, or we can use the Visual Studio Solution Runner. And they are almost equivalent. They're very small, subtle differences. But if you don't have any good reason to select MS Build, you should select Visual Studio. So the step name is automatic. And we only want to execute this step if all previous steps were successful. There are no previous steps, so this will always be executed. The only thing that we require to configure here is the solution file path. The path to the solution file we want to build. And you can click this icon and TeamCity will connect to the version control system that we configured just a minute ago. And you can just select the solution file from here. Don't even have to type anything. The next step is to select which version of Visual Studio you want to build on. And this will be a software requirement for the agent. So make sure that there is an agent installed that has Visual Studio 2012. If not, your solution won't ever build. So we specify rebuild as a target, and maybe we should have debug as a configuration, since we're now creating a build configuration that is supposed to run frequently and quickly and after each code change. So we're not exactly building a release candidate or a release. So we can leave this blank to use the default, which is any CPU. And I'll specify /m as a command line parameter to pass to MS-Build, because this will allow MS-Build to use all available CPUs. So in general, it will be faster, at least if the agent has more than one CPU. So that's it for our first build step. And you can go back and edit it or disable it, delete it, and so on. Now we're going to add our next and final build step, which is MS Test. We're going to use MS Test to run our unit tests. So step name is automatic. We only want to execute this step if all previous steps were successful. It doesn't really make sense to try to run the test if the build in the previous step fails. So that's fine. We select which version of MS Test we want to run, and then we can list which test assemblies we want to pass to MS Test. And there's a couple of ways you can do this, and I'll just copy and paste something in here. So one way is to list all the file paths to the test assemblies using relative paths, like the first line. Alternatively, you can use wildcards, as in this second line, to specify a file pattern, and then all paths that match this pattern will be passed to MS Test. This is probably more useful, so you don't have to update your TeamCity configuration as often. You can also do the same for test assemblies you want to exclude, and I'll give an example of that. Maybe you don't want to run your Selenium tests as part of this build configuration, which is running every time someone makes a change. Maybe your Selenium test suite takes a long time and you want to exclude that. So the next important option is the MS Test run configuration file, because here you also have an opportunity to run something in parallel. If you specify the path to a configuration file here in your repository, and that configuration file has a certain parameter that allows MS Test to use all the available CPUs, like we did with MS Build in the previous example, you can get your process to be faster. But obviously you have to make sure that all of your tests are able to run in parallel without problems. If you want to be even more specific about which tests you want to run, you can do that here. Say if you only want to run a certain subset of the tests that are available in the specified assemblies. Lastly, you can specify additional command line parameters, and I'll give a quick example of that as well. So for instance, maybe you don't want to run your integration tests in this basic build configuration, because the focus here is speed, right? So the integration tests, maybe they take a long time and you want to run them every night instead of every time someone makes a change. So this command line parameter would exclude all the tests that have the category integration tests. We also have the option of adding a code coverage tool. TeamCity comes with JetBrains.cover, and you can enable that here. But again, we're not going to do this for the basic setup. That's supposed to be very, very fast. I guess if you wanted to, you could measure the code coverage every time someone makes a change, and you could go to build failure conditions and say that we want the build to be marked as a failure if code coverage drops below a certain percentage. That's a possibility, but that seems a bit overkill to me. So let's skip that for now. This step has been configured. So we have 2 build steps, and there's only one more thing we need to do to complete our build configuration, and that is to add a build trigger. So here you can see the build triggers that are available in TeamCity. There is a version control system trigger. There is a schedule trigger, and those are the 2 most frequently used ones. And we're going to add a version control system trigger. Now, by default, TeamCity will check your repositories every 5 seconds. So let's say TeamCity checks your repository, it finds nothing new. It checks again 5 seconds later, and it finds 10 new commits. What happens? Well, with this default configuration, it will only build the latest commit of those 10 commits. So TeamCity will get the absolutely most recent code, and it will run that through your build process that you've set up, and that's that. If you want to trigger a build on each check-in, you can do that. So in the example I just described, TeamCity would build 10 times. You also have an option of including several check-ins in one build if they are from the same committer. So if the 4 first commits were from developer A and the 6 last commits were from developer B, if you configure TeamCity like this, it would build 2 times, one for developer A and one for developer B. But I think the default configuration is good enough in most cases. So let's add that trigger. Now if you go to the front page, we have a new project and we have a build configuration with no builds. So now we can obviously trigger this in 2 ways. We can make a change to the code, commit that to the central Git repository, which TeamCity is continuously monitoring, or we can click the run button, which is what I'm going to do. So now it has looked for an available agent, and we can look at the build log live here. And it's already finished, but what happened is that it got the source code from the Git repository. It built the solution using Visual Studio. It ran MS test. It found 1 unit test which passed, and then it generated some reports and parsed those reports and cleaned up. If you go back to the front page, you can see that now that the most recent build was successful. 1 test passed. It was 1 minute ago, and it took 5 seconds. So from this menu, we have the option to go back into the build log, but we already looked at that. You can look at the test report, which is not very exciting. We have 1 test that was successful, and you could go into the test details if you wanted to look at the history of that test, how long it took to execute in the past, and if it was successful or not, and so on. Now, instead of looking at the specific most recent build, we can look at the build configuration level. And here you would be able to see all the recent builds, or at least the 10 most recent ones, or something like that. On the history tab, you could see everything. And you have a statistics tab, which shows some charts that are usually interesting, but not when you only have 1 data point. So let's look at how this looks for a project that's been going on for a while. Let's see. Okay, so let's look at the nightly build for the International Payroll Court. Here you can see the recent builds. It shows the 15 most recent ones apparently. And let's look at the statistics tab. Now here we have some exciting graphs. We have test count, we have code coverage, we have the number of style copy violations, and we have the number of code inspections, which is the same as FX copy violations. And you can adjust over what period you want to look at these statistics, and yeah, you have some settings on most of them. Okay, I think that concludes what I thought I would show you. If you have any questions later or you need help getting started using TeamCity, feel free to contact me. Are there any questions at this point? No? I'll give it 5 more seconds if anyone has a question. Okay, well, thanks for coming, and have a nice day.